Okay, thanks very much. So I'm a mechanical engineer and I've been working in the timber industry for 30 years, but despite that, I'll try not to bore you too much. This is going to be kind of a technical presentation. Most of my career has been about the technical aspects of sawmilling, so process modelling, engineering, technology, capital, compliance, all that kind of stuff. But maybe 8 or 9 years ago, I was given the freedom to pursue a passion for sustainability within our business, and I've been really heavily supported by the business in that, and that's kind of helped us to get to where we are on our sustainability journey. So just a little bit about us as a business. So Timberlink, we're in the middle. That's who I work for. Next Timber is our business down the bottom. That's in the process of commissioning a new $60-odd million plant to build cross-laminated timber and glue-laminated timber. I'll go into that in a little bit. But we're vertically integrated essentially with the plantation owners. So we're all owned by investment trusts managed by New Forests. New Forests is now the second biggest forestry management company in the world. They manage about 10 billion of Australian funds, global funds. And their initial differentiator in their investment market was around their sustainability. So they've been a huge supporter of what we do. Probably the other part of this supply chain is that it's going to enable us to have FSC and PEFC certification from beginning to end on the product. So I can't claim that on the next timber product yet because it's not being manufactured. But that's the intent. The feedstock's all going to be certified, and once we're underway, the product will be certified as well. Okay, so we've got 2 manufacturing facilities. We've got in total about 600 staff now. The manufacturing facilities are in the north of Tassie, that's where I'm from, and Tarpeena in South Australia, up near Mount Gambier. So we're producing material from about 1 million tonnes a year of log. These are high-tech facilities. We use all sorts of laser scanning and acoustic scanning and high-speed colour vision, all that sort of stuff. There's a lot of technology in these mills. It's not just a bunch of people with some big saws. And it's a very capital-intensive industry. So we've spent, in 10 years of Timberlink, we've reinvested about 200 million into the business on some big upgrades and then also some incremental work as well. This is the Next Timber offering. So as I said, this is a new facility at our Tarpeena plant. To give you an idea of scale, the building's 200 metres by 40 metres. It's a 63 million investment in total. We're producing 2 product lines. So one's glue-lam timber beams, which you'd be familiar with for beams, columns. So we're going to be able to make them out to 12 metres long, 1 metre deep, straight or cambered. And then cross-laminated timber, which for those not familiar with it, it's big timber slabs used typically in multi-storey construction in place of concrete. The billets can be up to 16 metres long and 3.5 metres wide, 350 deep. As by way of an anecdote, there were 3 of us that did all of the plant procurement and everything for this plant, and we did the whole thing over COVID. So when everybody's talking about, you know, the change in ways of work, to go from a mode of working where if we were spending, you know, anything like that sort of money, we'd have people backwards and forwards to Europe or the US or whatever. We could spend that amount of money with a high degree of confidence just from interacting with people on the internet and swapping 3D models of the factory and all that kind of thing. And it's, well, we're about to commission it, and so far it's been very successful. I wasn't allowed to show you up-to-date photos of what it's like inside, but I'm sure once we've been running for a while and we've had a few visitors through, we'll be more than happy to run tourism packs for the right people.
Field trip.
Yeah, everybody loves industrial tourism. Even those who think they don't, they love it when they get there. Technical resources, so early on in the project, we sent a whole bunch of our material to a plant in Europe that had the same equipment, used the same adhesives, got a bunch of product made, brought it back and did all of the structural, fire, acoustic testing. So that's all now available. We've just released environmental product declarations. I'll talk about those in a little bit of detail in a second. And then here kind of starts the meat of actually what I wanted to talk about from a kind of technical point of view. So you'll probably all be aware globally buildings account for somewhere around 40% of energy-related carbon emissions. As we heard in the last presentation, even refurbished buildings are now reaching really high levels of operational efficiency in terms of energy use. So the more efficient we are at using energy within buildings and the greener the energy is that goes into the buildings, the more important the embodied energy that goes into the building and construction becomes. So, and I guess as somebody mentioned before, we're having to turn this marathon into a sprint. You know, we've only got a couple more decades to really make an impact. I'm probably just preaching the converted here, but just in case anybody's not 100% across this stuff, I will use a couple of technical terms. So 3 scopes of emissions. Scope 1, us burning diesel. Scope 2, us using electricity. Scope 3, everything in the supply chain. For us, Scope 3 is around 99% on our latest footprint. So huge, but Scope 1 and Scope 2 is what you can control generally. And then importantly, think about your emissions in 2 groups. So biogenic, so trees absorbing CO2 out of the atmosphere, turning it into a solid product, that's a biogenic sequestration. Burning wood in your fireplace, that's a biogenic emission. And everything else, which is fossil fuels related. So some basics. Doesn't get much more basic than this, I suppose. When a tree grows, sucks in carbon dioxide from the atmosphere, turns it into solid wood. If you look at IPCC reports, there's another report, I can't remember the guy's name, but talking about ACCUs. This is really the only meaningful way we have of capturing carbon dioxide at great volume at the moment is through forests or woody biomass. When these trees grow, convert atmospheric CO2 into solid wood, we turn that wood into wood products, and then that biogenic carbon sequestered within that product for the life of the product. So, you know, the more of that wood we can turn into long-lived building products and the less into tissue paper, the better. So that's a strong driver for us. Importantly, wood products in landfill have been found to degrade really slowly. In fact, virtually not at all over many decades. And in terms of just the biogenic, so that atmospheric CO2 that's absorbed, 1 cubic metre of our CLT or GLT will sequester 829 kilos of CO2 equivalent for the life of that product. So that's just the biogenic. One of my colleagues got me to put this in, and I wish he'd explained it a bit more to me before I did put it in, but basically, that's what happens when you employ people who are much younger and cleverer than you. So what we're talking about here is that, you know, the planet, until we started getting crazy and digging up coal and peat and burning it and all that sort of stuff, the planet did a pretty good job of absorbing CO2 from the atmosphere and turning it into, you know, oil and coal and those sorts of things. Since the 1700s, where we started digging things up and burning it, you know, we've depleted the carbon that's in the ground and put it up into the atmosphere. So that, I mean, I remember this being pretty well established science when I was a kid, and that was a hell of a long time ago. So despite what, you know, climate deniers may say, the science for this is pretty well established. The opportunity we've got now is to move on from concentrating our efforts on using these kind of mineral-based construction materials, which are depleting the carbon pool, into bio-based construction materials, which are going to replenish the carbon pool. So suck CO2 out of the atmosphere, put it into the built environment, and then maybe put it back into the ground. I can send you a link if you like the image, or I'll get Luca to send it to you. He's better with that sort of thing. EPDs. So an EPD is the standardised, verified way of quantifying all the environmental impacts of your material. So these are a full life cycle document. So if you're looking at trying to establish the life cycle carbon impact of your building, you need to be basing it on a proper full life cycle EPD, not on an in-out hybrid kind of thing like the EPIC database or something. You really need to use proper EPDs. They're prepared to ISO standards, they're verified by an accredited third party. These ours are registered by EPD Australasia. They're bloody expensive, in case anybody's wondering. Now to dig into them a little bit, this is out of our recently released EPDs. If you're wanting to have a look at the carbon impact of, in this case, your building, you look at the global warming potential, which is these numbers here. So probably the thing to highlight here is if you were to look at any EPD for steel or concrete or whatever, this number here is going to be pretty close to zero. I actually had a steel EPD on there, but I think our legal people must have taken it off or something. But anyway, trust me, or don't trust me actually, go to EPD Australasia and download a BlueScope EPD or something. What this number here, which is large and negative, is telling you is that the trees have sucked the CO2 out of the atmosphere. I'm going to repeat this in case anybody forgets. Turn it into a solid product and you can then make that into a building. If you're trying to compare two different ways of constructing a building and looking at the embodied energy, it's difficult on a product by product EPD basis. We as an industry are putting some efforts into trying to make that a bit easier. There have been some case studies. There was one from maybe 10 years ago, the Forte building in Melbourne, that showed a 22% lower total global warming potential using that mass timber rather than a conventional concrete construction. One of the issues with EPDs is end-of-life treatment of carbon. So when you think back to primary school, we learned about the carbon cycle. So you've got your wood, you know, ultimately at the end of the day, you might bury that wood in the ground. What happens to the carbon? Science has told us for many years that carbon's kept in the ground. I mean, it's actually kept in the form of wood for thousands and thousands of years. You wait millions of years, it'll turn into coal. That's the carbon cycle that everybody's aware of. Unfortunately, the latest version of the EN standard that deals with biogenic carbon mandates that in our EPD, we have to treat all of wood at landfill as being directly emitted to atmosphere. And I guess what I'm saying to you is that that's actually incorrect. I understand it was done for political reasons in Europe. They don't like landfill, so they thought they'd just not worry about the rest of the world and set a rule in a scientific document that was scientifically incorrect. So anyway, so this number here under the current rule is large. Biogenic carbon, they say, is emitted to atmosphere. If you look at the last version of that standard, and we put these numbers in our EPD because we're allowed to, the number was 50 instead of 930. So with the change of the standard, they've basically come out with this completely misleading result. Also in our standard, we've quoted these papers. Feel free to look those up. This is the research I referred to demonstrating that when you put wood in the ground, it stays as wood, doesn't get emitted to atmosphere. So I guess what I'm saying is if you're really interested in the actual life cycle impact of wood in a building, if the wood goes into a landfill, it's not all emitted. If you burn it in a furnace, it is all emitted, but even in that case, it's still essentially carbon neutral energy in terms of biogenic energy. It's not like digging up coal because we've regrown all of those trees. And then just back onto Timberlink. So one of the things I really wanted to do was to commit us to carbon targets. Yeah, I'll be quick. Last slide. So, you know, all this talk about biogenic carbon, that's fantastic, but as a manufacturing industry, we use energy. We use forklifts that currently run on diesel, hopefully won't be for too many more years. We use electricity, so I think it's up to us to reduce our carbon impact. So a couple of years ago, we went through a process, got our carbon footprint done, calculated carbon targets according to the rules of Science-Based Target Initiative. So if anybody's not aware, that's the big international body that dictates how every industry and every country has to decrease their emissions in line with the Paris Agreement. So what we chose the 1.5 degree target because that was the more ambitious one. And these are the targets we ended up with. So the key one is a 53% reduction in Scope 1 and 2 emissions. After 3 years, we'd got halfway there on our way to 2030. So we're pretty comfortable with where we're going with that currently. And we've just about finished off the process of redoing our carbon footprint and resetting targets. And because they're science-based, the targets get harder. So this 53% will go up to about 60. Okay, thank you very much.